Open Google Earth. Zoom out. Most of the planet is water. From up here, the ocean looks simple, just blue, quiet, almost empty. But the map is lying to you, because the deepest places on Earth don't look dangerous. They don't have warning signs. They don't look like cliffs. They look normal, and that's the trap. Down there, the ocean isn't water anymore. It's pressure. Pressure so constant and so heavy, it can crush metal and end a mission instantly. Tonight, we're not doing a countdown. We're doing something worse. We're moving from the places that are still survivable with modern exploration to the places where survival becomes a thin engineering miracle. And the deeper we go, the more the rules change. Not because the ocean gets louder, because your margin disappears. Here's how this ranking works. We're judging each place by one question. How survivable is it if you actually try to reach it? Not could you swim there? Not could you dive there? I mean, could an expedition reach it, operate there, and come back reliably? Two things decide that. First, logistics. Weather windows, distance, surface conditions, and how often crews can even attempt the site. Second, unforgivingness. If something goes wrong, how much time do you really have before the ocean ends the story? Now, quick pressure reality, without turning this into a math lesson. Every time you go deeper, you add weight, and the ocean doesn't add it in a way you can feel gradually. It stacks it on top of you, silently. At a few hundred meters, you're already beyond what a human can survive. At a few thousand, you're beyond most conventional diving technology. And by the time you're in trench territory, you're not underwater anymore. You're inside a sealed pocket of air, protected by a pressure vessel. That's why deep submersibles feel more like spacecraft than boats. They're built to keep one tiny space normal, while the outside becomes impossible. Also, you'll hear depth numbers. They can vary slightly between surveys, because trenches are steep and mapping isn't perfect. Sound travels differently depending on temperature and salinity, so surveys use water column measurements to correct the math. Then they run multiple passes from different angles to reduce shadow zones on steep walls. So I'll use widely reported depths and keep it realistic. The exact meter doesn't matter as much as what never changes. The deeper you go, the less room you have for mistakes. One more thing. The deep ocean doesn't look scary. It feels scary after you understand the rules. No light, near freezing water, and pressure pushing in from every direction, every second. So as we go deeper, listen for the real villain. It's not an animal. It's not a storm. It's physics. All right, we start with deep places that are extreme, but comparatively survivable. Google Earth. Move to the Indian Ocean, south of Indonesia. From high altitude, you don't see a hole. You see a long scar in the seafloor, like a seam running through the planet. This is the Sunda Trench, often called the Java Trench. It exists because tectonic plates collide here, and one plate is forced beneath another. That's the first pattern of the deep world. Many of the deepest places on Earth are subduction zones. They aren't random pits. They're boundaries, active, moving edges of the planet. Survivable is a strange word here because we're still talking about multiple kilometers of black water. Sunlight is gone. The temperature drops toward near freezing, and the environment becomes steady, quiet, and brutally indifferent. So why does this sit on the survivable end of our ranking? Because in the world of deep exploration, not all deep is equal. Some places are extreme, but still reachable within realistic logistics. This region is closer to established operating zones than many remote trenches. It's been studied, mapped, and revisited, which matters more than people realize. Deep ocean survival is a chain. Your ship has to arrive and hold position. Your launch has to be clean. Your recovery has to be clean. Your navigation has to stay stable. And your vehicle has to remain sealed, perfectly sealed, while the ocean presses inward. And here's what deep missions feel like in real life. A descent is hours of quiet. Teams watch readouts. They listen for anything unusual. They run checklists again, even when nothing is happening, because the ocean doesn't wait for your confidence. Then, at the bottom, your lights catch the seafloor like a stage appearing out of darkness. It can look calm, almost boring. That calm is a trick, because the pressure never stops. If your air pocket stops being protected, the story doesn't become dramatic, it becomes instantaneous. That's why even the most survivable trench on this list still feels terrifying. It's not survivable because it's gentle. It's survivable because it's comparatively reachable and comparatively manageable for modern operations. But once you understand how thin the margin already is here, you realize what comes next. Because the next places aren't just deeper. They're harder to reach, harder to predict, and harder to recover from. Now jump to the Atlantic. Google Earth, move north of Puerto Rico. From above, it looks harmless, a faint line, a subtle shadow in the water. This is the Puerto Rico Trench, the deepest region of the Atlantic Ocean. And the reason it sits lower on survivability is psychological. It hides under a world that feels familiar. You're near islands, near air routes, near shipping lanes, near cities. So your brain wants to believe the ocean below is normal. But this trench drops into the 8-kilometer class. And at that point, nearby doesn't matter. Because if you're down there and something fails, the surface world is still unimaginably far away. On land, danger usually announces itself. You could see fire. You could see cold. You can hear storms. In the deep ocean, danger is invisible. The water looks calm while it applies crushing force. This is where survivability begins to depend less on bravery and more on boring reliability. Sensors that don't lie, thrusters that don't hesitate, power systems that stay stable, communications that remain usable. And even that last part is important. At depth, you're not using normal radio the way we do on land. Teams often rely on acoustic systems that are slower and more limited. So you may not have a full, constant conversation with the surface. Sometimes you have updates. Sometimes you have short messages. And sometimes you have silence. Not because anything is wrong, because physics limits how you can talk through kilometers of water. That changes the psychology. You could be deep, in the dark, with a limited link to the world above, trusting that your systems are still normal. And that's why this trench feels less survivable than it looks on a map, because it teaches the same lesson as the deep itself. Proximity does not equal safety. Next, let's go to the Eastern Pacific. Google Earth. Trace the coast of South America, from Peru down through Chile. Running along the edge is a trench system that extends for thousands of kilometers. This is the Peru-Chile Trench. It matters in a survivability ranking because it's deep, vast, and tied to a tectonic boundary that can release energy violently over time. Now, this isn't a prediction of disaster. It's context, because when you operate near an active boundary, you plan differently. You think about seabed topography changing. You think about slope stability. You think about whether you're descending into a basin where sediment can behave like soft powder, or into a steeper wall that can complicate navigation. And this is where another deep-sea reality becomes obvious. The deeper the mission, the more time becomes risk. A deep descent takes hours. Then you work at the bottom. Then you ascend for hours. So every extra hour is another hour of pressure on seals, joints, cables, batteries, and human decision-making. The deep ocean doesn't rush. So problems don't always explode immediately. Sometimes they build. A small drift in a sensor, a temperature change in a system, a thruster drawing slightly more power than expected. These are not movie moments. They're little warnings that only matter because you're so far from any easy escape. That's what makes survivability drop as depth rises. You don't die because you panic. You die because you ran out of margin. And at these depths, margin is the rarest resource. Now, pull the map far south, into water that feels like the end of the world. The South Sandwich Trench sits in a region where the surface itself becomes a threat. This is where survivability drops even if the depth is only in the deep trench range, because here, logistics become the killer. The Southern Ocean is famous for violent weather and relentless swells. Your ship has fewer safe windows. Your operations become harder. Launching and recovering equipment can be dangerous even before you ever start the descent, and that changes something fundamental. In many places, if you have the right vehicle, you can attempt the dive when you're ready. Here, the ocean tells you when you're allowed to try. And if it says no, you don't negotiate. A crew can spend days waiting for a break. Then a small window appears. You launch. You descend. And all the time, you know the surface can turn against you before you come back up. This is why reachability is part of survivability. Because rescue is mostly a fantasy at trench depth. Not because people don't care. Because time and conditions make responses unrealistic. So in a remote ocean, even a minor problem can snowball. If something breaks and you have to abort, you might not get another window for weeks. Your mission can fail without a single dramatic event. Just the ocean refusing to cooperate. And when you realize that, you understand a new kind of fear. Not a sudden disaster, but slow failure in a place where you don't get another chance. Google Earth, Northwest Pacific, off Russia's Far East. A long trench running beside volcanic arcs, shaped by active tectonics. This trench pushes toward the high 9-kilometer class. And this is where the ranking begins to change meaning. Because your margin becomes thin even inside the vehicle. At these depths, it's not enough to have a hull rated for pressure. You need a hull that can take that pressure without micro failures. You need seals that don't degrade. You need electronics that don't drift. You need reliability. Because one good dive isn't a strategy. Navigation also becomes more unforgiving. Trenches are steep. Your lights illuminate only a small cone, so you rely on maps, sensors, and careful descent profiles. If your mapping's off, you can approach the wrong slope or the wrong basin. And if you're too close to a wall, even small movements can feel dangerous. This is where the deep ocean begins to feel like a place you can visit only if the entire chain behaves. If one link fails, the ocean doesn't give you a second chance. It gives you a lesson. And there's a psychological moment here that expedition teams rarely talk about. It's when you realize the outside environment is not merely hostile. It is dominant. Your technology is the only reason you exist down there. That awareness changes everything. It turns exploration into quiet, constant caution. Google Earth, off the northeast coast of Japan. The Japan Trench sits in a region shaped by powerful tectonics and steep seafloor geometry. In survivability terms, it's reachable compared to remote oceans. But it's unforgiving in a different way. The trench walls can be complex, the slopes can be steep, and the environment can challenge operations through currents and surface conditions that change quickly. This is also a place where you're reminded that the deep ocean is connected to the surface world. Not in a poetic sense, in a physical sense. Subduction zones and trench systems are part of the same machine that shapes earthquakes and can influence waves across entire basins. Again, that doesn't mean you're guaranteed disaster. It means you're working in a system that demands respect. A deep mission here is an operation. Ship position, vehicle descent, vehicle ascent, recovery, all of it coordinated. If you watch footage from trenches, the bottom can look oddly peaceful. Sediment, scattered rock, slow movement. It can feel like nothing is happening, but pressure is happening. Constantly. And that makes the quiet unsettling. Because you know the ocean would end you instantly if the shell failed. This is where time becomes a character again. You don't want to rush, because rushing causes mistakes. But you also know every extra minute adds exposure. So missions aim for efficiency, not speed. Get the data, get the samples, get out. Google Earth, move south of Japan, following the arc system toward the Mariana region. This trench corridor sits on the path into the Hadal zone. And at this point, the story changes. Because this is where deep becomes almost alien. The deeper you go, the less the ocean feels like exploration, and the more it feels like negotiation. Not with a government, not with a fence, with the laws of physics. At these depths, even small failures matter. A sensor reading that lies, a thruster that hesitates, a valve that sticks. None of these are automatically fatal, but each one eats margin. And margin is everything. The Hadal zone is where sunlight has been gone for miles. The water is near freezing. The pressure is relentless. And the only reason a human can witness it is because a pressure vessel protects a pocket of air. That's why deep-sea vehicles feel like spaceships. They're designed for an environment where you cannot survive outside the hull for even a moment. They carry redundant systems because the environment punishes improvisation. Even when everything works, you still don't conquer the trench. You visit it, you collect data, you leave. Because the ocean's advantage is permanent. The pressure doesn't get tired. The darkness doesn't change. The cold doesn't negotiate. Now we step into the 10-kilometer class. This is where survivability drops hard. Google Earth, northeast of New Zealand again. The Kermadec Trench is a long, deep cut in the planet. And here we enter the 10,000-meter zone. 10 kilometers doesn't just sound deep. It changes the mission. A descent to this depth takes hours. Then you work at the bottom. Then you ascend for hours. So you're not surviving pressure for a moment. You're surviving it for a full cycle. This is where deep-sea exploration becomes an endurance test for systems. Seals, joints, connectors, batteries, thrusters, computers, even simple moving parts. And the psychological weight here is unique because you're committed. If something feels wrong, you can't instantly escape. You can abort, but aborting is still a long process. So uncertainty becomes its own kind of stress. Even a successful dive can feel tense because the biggest danger is invisible. Your hull can look fine. Your cabin can feel normal. But outside, the ocean is pressing with an intensity that never eases. That constant load is why engineers obsess over tiny details. Surface finish, weld quality, seal materials, redundancy, and testing. Because at 10 kilometers, tiny weaknesses are not tiny. This is also where rescue becomes almost purely theoretical. A vehicle that can reach 10 kilometers is rare. A vehicle that can reach 10 kilometers quickly is rarer. A vehicle that can reach 10 kilometers and then perform a rescue task under pressure is rarer still. So survivability is dominated by one strategy: prevent failure, avoid improvisation, and respect the fact that time at depth is exposure. Google Earth, Western Pacific near the Philippines. Within the Philippine Trench lies Emden Deep, one of the most extreme points of depth outside the Mariana system. Here, you're in the 10.5 kilometer zone. And at this point, the surface stops feeling real. It becomes an idea, a direction, a line on an instrument. This is where language starts to fail. Because what does deep mean when you're so far below the surface that even the concept of up feels like a distant thought? But this is also where the documentary story stays grounded. The deep is not empty. Research has shown life at these depths. Organisms adapted to pressure and cold in ways that challenge old assumptions. That's not a horror detail. It's a scientific one. The Hadal zone is harsh for humans, but it's still an ecosystem. And that contrast is unsettling, because it reminds you that the environment is not evil. It's simply not for you. If you're exposed here without protection, your body cannot function. Not slowly, immediately. And the deeper you go, the more your survival depends on perfection. Not courage, not skill, perfection. This is where expedition planning becomes obsessive for good reason. Redundant systems, checklists, emergency protocols, teams that rehearse failures before they ever leave port. Because the deep doesn't forgive mistakes that are survivable on land. If you're into investigations like this, real locations, real expeditions, real physics, subscribe and hit like, because it tells YouTube you want documentary research and map-based storytelling, not exaggerated creepypasta. Alright, the final places change the rules. Google Earth, back to the Mariana region. Most people know one name, Challenger Deep. But the Mariana system has multiple extreme basins. One of them is Sirena Deep. At this depth class, the Hadal zone becomes the main character. No sunlight for miles, near freezing water, pressure that dominates everything, and the deep plays a psychological trick. From above, it looks calm, so your brain wants to believe it's calm. But calm water doesn't mean safe water. It means the danger is hidden. Inside a full-depth submersible, you're not in the ocean. You're inside a protective shell, watching the ocean press inward. This is what forbidden looks like in nature. No fence, no sign, just an environment your body cannot exist in. And the deeper you go, the more pressure stops being a number and becomes behavior. Materials flex differently. Electronics behave differently. Simple mechanical systems can respond in ways they never would at the surface. So every descent carries a quiet question. Will your machine still be your machine after hours under this load? Google Earth, South Pacific. Within the Tonga Trench system lies Horizon Deep, an extreme point that sits just a thin margin above the deepest confirmed place on Earth. And that closeness is what makes it terrifying. Because if you hear a depth around 10.8 kilometers, your brain wants to label it the bottom. It should be the bottom. It feels like the bottom. But it isn't. And that changes the way you see the planet. It means the Earth's deepest points are not just one famous location. They're a category of places where human capability is stretched to its limit. Horizon Deep also represents another truth about deep exploration. Our understanding keeps sharpening. Better mapping, better correction, better resolution. The trench isn't changing in real time, but our picture of it can. And at these depths, even a small measurement difference feels like an entire world. And there's another factor that makes this place less survivable than people expect. It's not just depth, it's remoteness. You're operating far from immediate support. You're dependent on the mission chain staying intact. And if anything forces an abort, you may not get a second attempt for a long time. Now we reach the least survivable place on Earth. The final step in the ranking. Not because it's mythical, because it's real, confirmed, and still barely reachable even with the best engineering we have. Google Earth, Western Pacific, near Guam. From above, it's still the same calm blue surface. And that's the strangest part. The deepest place on Earth doesn't look like anything. But below is Challenger Deep, the deepest confirmed point on the planet, just under 11 kilometers. At that depth, the environment is not difficult. It's incompatible with the human body. If you were exposed, you wouldn't have a dramatic struggle. Your body would simply stop functioning. So survival here is not courage. It's engineering and discipline. Full-depth missions rely on redundancy, backups, procedures designed to avoid improvisation. Because improvisation at full depth is admitting the plan is breaking. And you don't get many chances to recover a broken plan under that much pressure. And this is where the word pressure finally becomes real. Over 1,000 atmospheres pressing on the outside. Imagine the weight of a mountain, but applied evenly, constantly, from every direction. That's what your hull is holding back. Challenger Deep isn't a simple pit either. It's a complex set of basins and shapes. The deepest spot depends on precise positioning and correction. So when researchers refine the number, they aren't changing the trench. They're sharpening our picture of the most extreme environment we can currently confirm. Now imagine the emotional weight of the actual dive. Hours of descent. The surface becomes a memory. The light is artificial. The world outside is black. The only sound is systems, and occasionally the quiet awareness that every meter down increases the stakes. Then the bottom appears. Not like a cliff face, often like sediment, soft slopes, scattered rock. It can look peaceful, but it isn't peace. It's indifference. And when you're down there, The biggest fear is not what you see, it's what you can't see. A seal you can't inspect, a crack you can't notice, a component you can't repair, because if the hull fails at full depth, there is no second chance. That's why, in terms of survivability, this is the end of the road. A place you can visit only through technology, a place you can never belong. Challenger Deep isn't just a coordinate, it's a mirror. It shows us how much of Earth we can map, and how little of it we can truly inhabit. So what did we actually rank tonight? Not just depth. We ranked the moment the environment stops giving you warnings. On land, danger is usually loud. Fire, storms, falling rock, distance. In the deep ocean, danger is quiet. You can descend in calm water, and if something goes wrong, it doesn't escalate like a movie. It ends like physics. And the deeper you go, the less survival depends on skill, and the more it depends on preparation, redundancy, and systems performing perfectly for hours. From Google Earth, trenches look like lines. From inside the trenches, those lines are the edges of human capability. Google Earth can show you where the deepest places on Earth are. It can't show you what it feels like down there. Click the playlist now for more forbidden and unreachable places like this. See you there.